Hello, and welcome to this presentation about the application of engineering. Throughout the next 5 minutes, we will be discussing engineering as a whole, as well as the real-life applications, specifically in relation to robotics. Before we can get into the applications of engineering, it is important to understand the engineering process as a whole. The engineering design process is split into 8 main sections: ask, research, imagine, plan, create, test, improve, and finally repeat. Although there are many variations to this process, these 8 basic steps encompass the necessary actions engineers must take to combat problems. The first step to the design process is to ask questions. Identifying the needs of a population is critical to develop solutions. An engineer must ask many questions in order to determine a suitable topic for development. Next, an engineer must research the topic in detail. It is important to understand the background information of a subject as well as the prior attempts at a solution in order to build the most effective plan. Then comes the fun part, which is to imagine. Once a suitable topic has been selected and the background research has been completed, engineers must brainstorm viable solutions. This step usually requires a large amount of time, as the process of coming up with ideas is often challenging. After the final idea has been selected, engineers must plan out the details and specifics of their plan. This step is very similar to the CAD design process in FIRST competitions, as teams should plan out their robot design before they get straight to building. This step ensures large errors are avoided and the engineering team has a path to follow without building blindly. Once the plan is solidified, that's when the building happens. These next 3 steps are rather connected, as engineers must create a design, test it, and improve it in order to work out the kinks. This step is critical to perfecting the design. Finally, once the project has been completed, the process repeats itself with a new topic, as there are countless questions engineers could combat. Now that we understand the engineering process, we can begin to look into the general applications of robotics. You might be wondering, where can I use robotics in my life outside of the FIRST program? Well, in the real world, there are many applications for robotics, 3 of which are transportation, medicine, and education. In transportation, engineers are looking into the development of automated transportation. Automated transportation relates to self-driving vehicles, which should not be confused with robots driving cars. People all around the world are looking to program cars as well as buses, trains, and trams in order for them to operate without human interference. Companies such as Audi, Mercedes, and Google are already starting to explore these applications. In addition to transportation, medicine is a huge area for real-life robotics. Medical robots such as micro and nanobots are capable of doing precise and accurate tasks that humans might not be able to perform. Many engineers are researching this field as it is a very prevalent discussion in the engineering and medical community. As of now, scientists have just brushed the surface of the endless possibilities of medical robotics. Finally, education marks the 3rd prevalent area of modern-day robots. Educational robots can be pre-programmed with lessons and subjects for younger kids to use to better develop their learning. Although this is also a newer field within the robotic world, engineers are looking to apply this technique for combating the learning gap within many developing nations where there might be a lack of teacher support. To go into more detail of medical robotics, scientists are looking into using artificial muscles to power robots responsible for disaster response. Disaster response robots could be very beneficial within modern society. However, improvements in robot design must be achieved before the disaster robots are functional. Christoph Keplinger and his team are looking into the use of soft components inspired by muscle and skin to help build robots with agility and dexterity. There are many challenges that arise for Christoph and his team. However, by using the engineering design process, they have a bright future. Additionally, engineers are also researching the use of soft, flexible robots to combat a multitude of tasks. Bendable camera robots can be used to examine a patient in a less invasive way compared to stiffer alternatives. Also, the development of soft, flexible needle robots is also a prevalent topic, as these tiny needles could be used to steer around organs and target tumors within a patient. As you can see, the possibility of robotics in the real world is endless. To conclude with the wise words of Bill Gates, robotics and other combinations will make the world pretty fantastic compared with today. Thanks for watching! This presentation was brought to you by ACE Robotics, Team 15430. If you have any questions, feel free to contact us at acerobotics15430@gmail.com. We look forward to hearing from you soon and hope you have a great season.